Alright, this is 9.1 part 2. So we're continuing with our right triangle trig stuff. So we have our two special right triangles here. If you remember from geometry, we have a 30, 60, 90 triangle and a 45, 45, 90. And this little chart here tells us all of our trig functions for those special angles in a 30 degree, 45, and 60 degree angle. So if we had the sine of 30, that would be 1/2. No matter what, if we had a triangle that was this big or a triangle that was this big, if this angle is 30 and this angle is 30, the sine of 30 is always going to be 1/2. If we took the tangent of 45, the tangent of 45 is always 1. So when you have your notes for your test and your quiz, make sure this is on it. This table is super helpful to have in front of you, and for the next couple of examples, we're just going to refer back to this table. So let's look at example 3. We have to find the value for x for the right triangle. So we want to ask ourselves, if 30 degrees is our theta, this angle here, what is x in relation to theta? Well, we know this side is opposite, so that means x must be adjacent. And 8 is opposite of our right angle, so that has to be the hypotenuse. So we need to see what involves adjacent and hypotenuse out of sine, cosine, or tangent. So looking back to our SOHCAHTOA, adjacent and hypotenuse go along with cosine. So we know that the cosine of theta, which here tells us that our theta is 30 degrees, so cosine of 30 degrees is equal to adjacent over hypotenuse, so x over 8. We refer back to the table on the last slide to see what the cosine of 30 is. Cosine of 30 degrees is square root 3 over 2. So square root 3 over 2 is equal to x over 8. And we have a fraction is equal to a fraction, so we can cross multiply. So we have 8 square root 3 is equal to 2x. Divide both sides by 2. So x is equal to, we can divide 8 by 2, which would give us 4 square root 3. And that's our value for x. For number 5, find the value for x for the right triangle shown. So we're doing the same thing. We need to see what x and 6 are in relation to our angle here. So x is right next to it, so this would be adjacent. And opposite of our 90 degrees is our hypotenuse. So again, we have adjacent and hypotenuse. We can look at our SOHCAHTOA. We know that cosine involves adjacent and hypotenuse. So we could say the cosine of 45 is equal to adjacent, which is x, over hypotenuse, which is 6. So we need to go back to that chart and see what the cosine of 45 degrees is. So cosine of 45 is square root 2 over 2. And that's equal to x over 6. So I just looked at my chart to see what the cosine of 45 is and plugged that in here. So I'm just replacing cosine of 45 with that square root 2 over 2. Now again, I have a fraction is equal to a fraction, so I can cross multiply. So I have 6 square root 2 is equal to 2x. I'm solving for x, so I'm going to divide both sides by 2. 6 divided by 2 is 3. So 3 square root 2 is equal to x. Example 4. So for this one, we need our calculator. And we're going to be solving the triangle. So to solve a triangle, we have to find the unknown side lengths and angle measures. So we have to find everything here. Remember, all triangles are going to have 3 sides and 3 angles. So we just have to find whatever is missing. If we start with the angles here, we have 28 degrees and 90 degrees. we know that all three angles in our triangle are going to add up to 180. So we could say 28 degrees plus 90 degrees plus whatever angle B is, so I'm just going to call it angle B, you can call it X, you can call it whatever you want, is equal to 180. So if it gives you two of the angles, you can always subtract from 180 to find the missing angle. So 28 plus 90 is 118. So I'm going to subtract 118 from the left and on the right. So angle B is equal to 62 degrees. Another way we could solve for angle B is we know that all of these triangles are going to be right triangles. So the two acute angles, 28 and whatever the missing one is, so not the right angle, they're going to add up to 90. So you can always just do 90 minus the other acute angle that was given, so 28, and that would give you 62 as well. All right, so we found the missing angle. Let's find our missing sides. So we can say 28 is our theta. So this is the angle that we're dealing with right now. If we want to find side A first, A is opposite of 28 and B is adjacent. So looking at SOHCAHTOA, tangent involves opposite and adjacent. So we would take the tangent of 28, and that's equal to A, opposite, over adjacent, which is 15. And then we would want to put the tangent of 28 into our calculator. When you use your calculator, one, make sure you know how to use your calculator. Sometimes you have to put 28 before the tangent. In some calculators, you just put tangent of 28. And you also want to make sure your calculator is in degrees. We're dealing with degrees here, so make sure your calculator is in degrees to solve these. So tangent of 28 is 0.5317, and that's equal to A over 15. To get that 15 out from our denominator, we need to multiply both sides by 15. So we get 7.97. We can just round it to 3 decimal places, so 5/6 is the next two, so we can round up to 6, and that's equal to A. So that is our opposite side. Now there's different ways that we can solve for side C. We have two sides of our triangle. We can do Pythagorean Theorem to find the third, or we can use one of our trig functions again. So I'm going to now use this angle here as my theta, angle B. So we said this was 62. I'm going to say 15 is opposite now. Since my theta is different, this is now opposite. And C is the hypotenuse. So sine involves opposite and hypotenuse. So I would take the sine of 62, and that's equal to 15, opposite, over hypotenuse C. So this one's a little bit different. When your variable's on the bottom, we still have to multiply C on both sides to get it out from the denominator. So I have C times the sine of 62 is equal to 15. Now I want it to be C equals, and since C is being multiplied to sine of 62, I'm going to divide sine of 62 to move it to the other side. So we get C is equal to whatever this is in our calculator. So depending on what your calculator can do, most people can do 15 divided by, make sure you put this into parentheses if you're going to put it all into your calculator at once. So when we put it into our calculator, we get 16.988. So I'm doing it in my phone calculator, which it may be a little bit off, so you get some, if you get something close, but that's just like a couple decimal places off, you're probably right if you put it all into your calculator at once. So just be careful when rounding if you do it in separate steps. All right, the next one. So this is like 4 different questions of the same thing we just did. So we have to solve the triangle. So we have to find all of the missing pieces given what it gives us for each one. So number 6, angle B is 45. Angle C is, or side C is 5. So angle B is 45. We know that the 2 acute angles of our triangle are going to add up to 90. So we would do 90 minus 45, which gives us 45 degrees for angle A. So we found our missing angle. Now we got to find the 2 missing sides. So it doesn't matter which one. I mean, they're the same, 45 and 45. So we can use this 45 degrees and call this theta. So that would make A opposite, and 5 is the hypotenuse. So we could say sine of 45 is equal to opposite over hypotenuse. So A over 5. Now sine of 45 is one of our special angles, so we can go back to that chart to figure out what exactly sine of 45 is. So sine of 45 is square root 2 over 2. So square root 2 over 2 is equal to A over 5. We can cross multiply. So 5 square root 2 is equal to 2A divided by 2. So A is equal to 5 square root 2 over 2. And we cannot simplify that because that 2 is inside the radical. So these don't cancel out. You cannot do that. All right, next we need to find, we just found A, so let's find B. So I could say that this is now my theta that I'm looking at, and B is opposite, and I'm going to use the hypotenuse again, which is 5. So sine of 45 is equal to B over 5. So sine of 45 is square root 2 over 2. That's equal to B over 5. Cross multiply, then divide. So cross multiply, we get 5 square root 2 over is equal to 2B, divide by 2. B is equal to 5 square root 2 over 2. We also know, since this is a 45, 45, 90 triangle, B and A are going to be the same thing because it's technically isosceles, because 45 and 45. So that's why they're the same. All right, next let's do number 8. So I'm going to erase everything I have here and just start over. So it tells us A is 71 and side C is 20. So we know that our acute angles of our triangle, so A and B, are going to add up to 90. So to find what angle B is, we can say 90 minus 71, which gives us 19. So angle B is equal to 19 degrees. Now let's find our missing sides. So if I say that this is my theta, A would be opposite and 20 is the hypotenuse. So I could say opposite over hypotenuse would be sine. So sine of 71 is equal to A over 20. I'm solving for A, so I'm going to multiply 20 on both sides. So 20 times sine of 71 is equal to A. Then I just need to put this into my calculator. So sine of 71 is 0.9455, and then multiply that times 20. And I get 18.910. So that's side A. Now we need to find side B. So still using this as my theta, I could say that B is adjacent and 20 is the hypotenuse. So adjacent over hypotenuse would be cosine. So the cosine of 71 is equal to adjacent, which is B, we don't know that, over 20. Multiply both sides by 20 because we're trying to solve for B. So 20 times cosine of 71 is equal to B. And I would just put this into my calculator. So cosine of 71 times 20 gives me 6.511. We're going to do one more of these just because I don't want the video to be super duper long for you guys. So let's look, we did 6 and 8. Let's do number 9, another special right triangle. So, actually, I want to do 7. So we have our triangle, I'm just going to redraw it here. This was A, B, C, C, A, B. Angle A is 32 degrees. Always be careful because like the sides and the angles are called the same thing, A, B, and C, A, B, and C. The angles are always going to be the capital letter, but it'll also give you that little degrees up there. So 32 degrees is talking about the angle. B is equal to 10. It's a lowercase b, so that is talking about the side B. So we can find what our missing side is, our missing angle, sorry, because we know our two acute angles are going to add up to 90. So we have 90 minus 32, which is 58. So that gives us angle B. So angle B is 58 degrees. Next, we can let's find side A. So A is opposite of 32. B is adjacent, so we can say tangent of 32 is equal to A over 10. So we multiply both sides by 10. So A is equal to 10 times tangent of 32. We just put this into our calculator. We get A is equal to 6.249. So one way we can solve for C is using one of our trig functions. So we can use A as 6.249, and we can say the sine of 32 is equal to A over C, opposite over hypotenuse. Another way, which we haven't done, so I wanted to do this one, an example to show you, is we can do Pythagorean Theorem. We have two of our sides, so we just use Pythagorean Theorem to find the third. C is going to be our hypotenuse, so we add our two sides together, so 10 squared plus 6.249 squared is equal to C squared. Remember that C, whatever it's equal to, has to be the hypotenuse. Then we just plug it into our calculator. So we want to put this into our calculator, then just take the square root of that, and we get C is equal to 11.792. So different ways that we can solve for C. You can use one of your trig identities, or once you have two sides, you can always do Pythagorean theorem to find the third. So that one is number 7, and we'll skip number 9 just for the sake of time. Example 5, we have a word problem. When it gives us the picture, it's pretty much the same thing we've been doing. It's not too bad. You are hiking near a canyon. While standing at A, you measure an angle of 90 degrees between B and C as shown. You then walk to B and measure an angle of 76 degrees between A and C. The distance between A and B is about 2 miles. How wide is the canyon between A and C? So we're looking for this length here, X. So we're going to use 76 as our theta, and x would then be opposite, and 2 is adjacent. I should probably change the color. Adjacent and opposite. So I could say, let's see what involves opposite and adjacent in our SOHCAHTOA. Opposite and adjacent go with tangent. So tangent of our angle, which is 76, is equal to x opposite over adjacent, which is 2. So I'm solving for x. I'm going to multiply both sides by 2. I have 2 times tangent of 76 is equal to x. So then I just want to put this into my calculator. So 76 tangent times 2. That gives me 8.022. And that's equal to x. So it's 8.022 miles. Because this was given in miles, so our answer should be in miles. The next one. If you look at a point above you, such as the top of a building, the angle that your line of sight makes with the line parallel to the ground is called the angle of elevation. At the top of the building, the angle between a line parallel to you and the ground is your line of sight, called the angle of depression. These two angles have the same measure. So, this isn't a problem, it's just an explanation of angle of elevation and angle of depression. If we have a horizontal line, and that horizontal line going down to form whatever angle that is, this would be our angle of depression. So it originates from the horizontal line and it goes down. An angle of elevation would be from a horizontal line upwards. So elevation. So both of them start from a horizontal line. That's probably the most common mistake most people make. They have to originate from the horizontal line. Angle of depression goes down, angle of elevation goes up. So example 6. A parasailer is attached to a boat with a rope 72 feet long. The angle of elevation from the boat to the parasailer is 28 degrees. Estimate the parasailer's height above the boat. So let's say our parasailer's up here. Our little parasailer is here. This is our person. Okay. And it's attached to a boat with a rope that's 72 feet. So this is 72. This is our boat. I'm not a very good drawer, but you guys get the point. The angle of elevation from the boat to the parasailer is 28 degrees. So angle of elevation is from the horizontal line up. So this is 28 degrees. Estimate the parasailer's height above the boat. So the height would be this length here. So let's call this h. So the hardest part of these is drawing the picture. Once you get the picture, then you just do what we've been doing. So 28 is our theta. We're looking at this angle. H would be opposite. 72 is our hypotenuse. So sine, because so involves opposite and hypotenuse, so we would say the sine of 28 is equal to opposite over hypotenuse, which is 72. Solving for h, we need to multiply 72 on both sides. So 72 times sine of 28 is equal to our height. And then we just put this into our calculator. So sine of 28 times 72 is 33.801. And then we're looking at feet, so this is in feet. And that's our answer. Alright, next one. In example 6, estimate the height of the parasailer above the boat when the angle of elevation is 38 degrees. So we have that same picture here, but now our angle is 38 degrees. The rope is still 72 feet long, and we're still trying to find this h. So we do the same exact thing. We're just switching out that 28 that we had on the last page for 38. So h is opposite, 72 is the hypotenuse, 38 is our theta, so we could say the sine of 38 is equal to opposite over hypotenuse, so h over 72. Multiply both sides by 72, so 72 times sine of 38 is equal to our height. So that gives us a height of 44.3276. I'm going to round up to 8. And this is in feet.